it should be live. Draftphysics.com, debatephysics.com, video presentation, and such. So just going over the usual, same old stuff, arguments. So I was working with the AI, and I had made some little flashcards, I guess you'd call them, to fill in some of the blanks in a narrative. And so I just figured I'd go over some of these arguments I've gone over before. And now to have this all pre-drawn, maybe I don't have to, just keep showing the cards and just say, oh, they got no counter argument for these simple arguments. And they never will have a counter argument because there's no possibility of arguing, that gravity's works some other way. So in this case, I'm just pointing out that you could drop an object 1 unit of distance. It goes 1 unit of velocity. You drop it 4 units of distance, and it goes 2 units of velocity, not 4 units of velocity. And it only uses 2 units of time to go 4 units of distance. And they're basically saying, the scientists, the ones with college degrees, are basically saying that somehow this force, that basically has to work like any other force, like sun. You get a suntan based on how long you're in the sun. It doesn't really matter how you move around or what you do while you're in the sun. It's just about how much sun, time. And gravity works the same way. It's the same inverse square law, lots of the same things. You got to know it's the same kind of force. You're going to collect it in chunks of time. All right, so it's only 2 units of time in the gravity. You can only collect 2 units of force. You only have 2 units of velocity. It takes 2 units of time. You'll weigh twice as much. So it all fits. And basically they're just saying, it's 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. And it's just wrong. That's not the same momentum. So those 2 objects, this heavy object has twice as much momentum. And they're saying that somehow something with twice as much momentum somehow will affect something exactly the same. It's the same energy, the same impact on a door, same impact on a bowling ball, anything. Somehow I can have 2 things with different momentums, and yet they will affect something exactly the same. Now, I say that's never happened in my life's experience. I've never seen anything like that. I've never seen it take 25 times the fuel to go 5 times as fast. What I have seen is just like what's up there. Half the weight, same force applied to half the weight, and it goes twice as fast. That's what I have seen. That momentum is conserved. I haven't seen kinetic energy conserved. Right there. Kinetic energy is not being conserved. You have exactly the same fan, exactly the same force being applied, and in one case you have twice as much kinetic energy. The yellow thing has twice as much kinetic energy by their theory. Even though it's half as massive, somehow if it hits something, it'll do twice as much damage, it'll accomplish twice the work. There's no evidence it's going to knock down quarterbacks. We see what guys look like who are supposed to knock quarterbacks down, and they're 400 pounds. They're not 50 pounds. All right. So anyway, it's and this is the big lie right here. The fact that they say gravity is 9.8 meters per second, and they put a square on here, and they just ignore what Newton and Galileo said, which is that, no, it's in 1 second units. It's 9.8 meters per second of increasing your velocity per every 1 second. That's what Newton understood. That's what Galileo understood. That's the real physics. And they just perverted it, destroyed the truth to sell a lie. And that's all they're really doing. So anyway, I've shown this drawing. You can do this lots of ways. Like I said, I could say that's a 4 mass dropped 1 foot. Like I said, this is a 1 mass dropped 4 feet. And I could explain these differences, or I could just say this is a same mass. And the fact is this is only going to have twice the energy, but it's only going twice the velocity. Because it was only in the force twice as long. And you can really understand the force is just being rain. And you're just collecting it in your mass bucket. Your mass decides how much rain you can collect, but you're going to collect it at exactly the same rate. So it doesn't matter how big your bucket is, it's going to collect the same proportional amount. And that's it. Depending on how big the opening is, that's it. So big opening, it collects a lot. A small opening, it collects a little. Big sail on a boat collects a lot of wind, little sail collects a small amount of wind. It's always going to be proportional to something that's doing the collecting. And in the case of gravity, obviously your mass is doing the collecting. Okay. Your electrons and protons are doing the collecting, and they collect at the same rate. Everything moves at the same speed, and it's just so obvious that it's about how long you're in the force. How long you're in the force differential will decide how much of the bent space you collect. Obviously, it's not bent space, but whatever. All right, so slide number 1. And slide number 2. So this is the rolling argument that also well illustrates, okay, the argument in the sense, that you can just see the same relationship exists, in the sense that if you roll with twice the velocity, you'll travel 4 times the distance, but you're not going to do 4 times the work because you're going really fast across this surface. So as you're going fast across the surface, you're way less on the surface. You're impacting the surface less because you're collecting less of this rain is in your bucket, so to speak. So the total amount you'll collect here is going to be the same as the total amount you'll collect here. But the fact is that that's over a huge distance. So your pressure, your weight, is the same over this giant surface compared to this small surface. So obviously your friction is not proportional. So it ends up being, yes, this is the same friction in this huge amount of distance that you did here. So the heat in the ground from your rolling, that's what's taking the energy. So you're converting linear rolling into little bits moving in the ground. It's just a momentum conservation. You're taking something big rolling, essentially moving, and you're converting it into little things moving. And the fact is you got twice as many little things moving here with twice the velocity, not 4 times. There's not 4 times the heat in this ground. There's only twice the heat in the ground. And the real giveaway is right here. 3/4 of the trip is where you're going half your velocity. And just like in this case, where 1/4 of your trip, you're going half your velocity. You're going half the velocity after just 1/4 of the trip. Well, you're doing the same thing here. 1/4, 1/4. This whole chunk, okay, is the same work done to the ground that you did here. Same 1 second of time. This is 1 second, this is 1 second, this is 1 second. So it's the same argument. You're just applying, you're taking the force, not in the same way. This consumes the same, this produces the same heat here that this produces here. It's going 1V here, it's going 1V here. Same. And it's over this distance, okay, that you didn't do the same work because it's spread out over this longer distance. So it's less force, less work. So the faster you're going, the less friction, the less pressure you have with the surface, the less you're pushing into it, the less possible resistance to your motion, the less exchange of, say, if you were you're full of electricity, you're making less contact when you go quicker. So I could just say this is the thin ice argument. Obviously, you could slide across thin ice. Okay, why can you slide across thin ice? Well, because you're doing this. You're taking your weight, which would look like this, and you're converting your weight into this. You're spreading it out over a much larger surface, meaning that your weight isn't going to break the ice because you are spreading it out. And it's that simple. And it's undeniable. I mean, unless you're going to deny you can't slide across thin ice by going fast. I can't get across a thin patch of ice by moving quickly. I mean, theoretically, I can get right across the water if I go quick enough, right? If I go quick enough, there's water skiers. I could show you a video of water skiers going quick enough, and they can just slide right on their feet. They're not sinking to the water, so they don't fall into the water. It's actually walking on water, you could argue. So if they walk fast enough, they can walk on water. Fact. I didn't make it up. It's just the truth. And we ought to be able to concede that, yes, that truth is completely incompatible with any notion of this nv squared silly quadratic increase with velocity notion of energy. It doesn't happen. It's not a fact. It doesn't physically. It's not a reality. You can slide across thin ice. You can water ski on your feet. All right. Next. All right, the simple gravity argument. Okay, so again, just proving the point, it's about how fast you're going through the rain, through the paint spray of gravity. So the only way this could be true is if you understand that gravity is functioning like a stream, like paint spray, like wind, something like that. That's what all these constant forces would have to basically function like. So the fact is if I want to go from point A to point B, the faster I go through this rain of gravity, this differential, this 9.8 differential, let's say the average across this straight line was 9.8. The fact is, the faster I go, the less I get bent. The less the stream, the faster I go across the stream in a boat, the less downstream I go, the less the current can affect me. And it's exactly the same thing here. It's exactly how orbits work. If I go just the right speed, I end up bending that line, of the curvature at exactly the same rate as my velocity is making it fighting against that curvature, and I end up in a perpetual cycle. But I mean, clearly, the slower I go, the more likely that I crash. I get pushed right in because I'm collecting. It takes more time. If I go slow, I collect more rain. My bucket gets heavier. I move towards the, I have collected more energy, so I move towards the object, and so it just a fact. And the less time I spend in the gravity, the less I'm bent. I mean, it's just a clear illustration. Again, I could just make this a stream. I could make this a paint spray argument and just say, obviously, the faster I go through the paint sprayer, the less paint I'm going to have on the object, right? So paint spray was coming out of my forehead, and I move this object quickly. It doesn't get much paint on it. I move it slowly. It gets a lot of paint on it. Duh. I mean, the fact I have to make this argument to college graduates. I mean, college graduates are denying these simple facts and saying that isn't true. That can't be how it happens. They have some reasoning to explain to me how it doesn't work that way, that somehow this magical gravity force somehow doesn't care how long I'm in the force. It doesn't care how long I'm in the paint spray. Well, how the hell can it work then? How does this gravity thing work if it doesn't have to obey these rules that every other constant force has to obey? Every force in the universe that creates an inverse square relationship, all of those forces, like photons from the sun, it just matters how long you're in the sun. That's what decides how suntan you get. How long are you in the sun? What kind of moving you do can't make any difference. And I have to explain that to college graduates. Okay. So simple arguments that all of the motion in the universe counts. Anything moving, all right, and it's called a thing. So if we're going to say a photon, now I'm going to argue a photon is ... A photon is made out of bits, 3 bits at a distance from each other. But everything is made out of, anything that you call a thing is a something, it has a mass, and if it's moving, it has a velocity. Obviously, all the forces are moving the speed of light. So it should be called the speed of force because all the forces are moving that speed, right? So that should be an obvious fix. We shouldn't be talking about the speed of light. We should be talking about the speed of force because magnetism, electricity, gravity, and photons all do this thing. Okay, it's not just light that does this speed of light thing. It's all of the discrete, elemental, quick-moving, invisible style sources of motion. all of the momentum that's in these tiny bits. Okay. And the rest of the momentum is something big, like an electron, a proton, an atom, a big giant clump of molecules, or a planet. Okay, big things move slow, small things move fast, and basically that's all you're really saying. And so things like heat is just the same momentum. It's just motion captured by material objects moving. So anytime there's a material object, electron, proton, or an atom, or anything moving, jiggling, doing something, it means it is, you can say it has to possess energy. It's using it. It's, renting it from the universe. Energy has attached itself to it. And so it's the same thing. So it's MV is in photons. MV can interact with matter, and now it can be pushing the matter. Then it can bang into something, release the photons back to being photons again. So it can go back from being pushing matter to being free again. Now I've used Sisyphus kind of an argument that there's just Sisyphuses, the force, and boulders, the electrons and protons, and that's all you really need to construct the universe. All right. Now, weight is just pressure, so this is just another concept where they've taken something that's really simple and tried to make it complicated. So obviously, I could just say, if I turn a scale sideways, I haven't broken any rules, and I can measure an impulse. That is, I can measure something's momentum, hitting it. I can collect the momentum in the scale, and it'll read as a weight. And so there's no conflict between understanding that the force that gravity is imposing on us, on every object that moves, and that creates weight, that it's nothing more than momentum. That I can move something at 1 mile an hour into a scale positioned horizontally, and it will, when it hits, have a maximum deflection of the spring that's going to be the same as its material weight. That is, the same weight it'll read in gravity is the same weight it'll read if it's going 1 mile an hour. So anything's mass times 1 mile an hour will equal its atomic, what we call its weight in gravity. So they're not exclusive things. They're exactly the same thing. There's no difference. Momentum is just weight. It's just heat. It's just force. It's just pressure. It's just the same thing. Everything is just momentum. You find out what the mass and the velocity is, and you know what you have as a quantity of energy. Okay. Let's see if we have any comments here. Oof. I believe we do. All right, audio is good. I saw you posted 30 minutes AI video you posted. Yes, it really did. It was a good... I had to add some of these things and stuff because it doesn't... The funny thing is it draws something so incredibly wrong. So it's like it does a spaceship and it, it'll have the exhaust, where the idea is you're supposed to be using thrusters from the sides, and it'll draw it from the nose, like you're shooting thrust out the nose of the spaceship and out of the back end. And then it drew like a one mass as like 4 times the size, and then the 4 mass is a 1 mass size. It got the 4 to 1 wrong. And so it is funny that it gets little things like that completely wrong. Like you would think it would know 1 would have to be small and 4 would have to be big. And it failed dismally on those simple things. But anyway, yes, it was a good video. It's quite interesting. It adds, it's flavor that it's adding, right? It's a seasoning engine, in the sense that it adds, it is capable of analogy, I think, of original analogy, of comparing two systems and seeing the similarity and then using that argument, like here's your brain on eggs, you know what I mean, on drugs, and they show the fried egg. It's sort of capable that I think I could actually do that kind of joke. And so, that's the part that's sort of interesting. I want to see if I can test that somehow, because I sort of think it's not very creative, but it might be able to be. It might be able to be creative in this completely just like poetry. Like if it was listening to sound, it would hear the words that sound alike, that rhyme, and it would be able to make analogies to rhyming words. So it is capable of doing. This is more than you need to know, but I'm just saying it is interesting. One of the dumb things that I did in my 20s was drive about 100 miles per hour. See, yeah, I didn't like going very fast. So I only did it a couple of times. And I said, why the fuck does anybody find this appealing? So I never liked going much quicker than 60. 60 seemed about, well, if something goes wrong, I can handle it. That's about it. And as soon as you go 70 and 80, you really get the feeling like if something goes wrong, you're fucked. And so I really never felt comfortable going 70 or 80. All right, my car seemed to be in less contact with the road. Yeah, that might be part of it too, is just the fact that everything gets slipperier, I couldn't measure the being compressed by the road, but it did seem. Yeah, I know. It's I had a very heavy car, so I didn't sense that as much, but that's part of it. I had a very heavy car, so I got the more of a sense that, if something goes wrong, I'm not going to be able to change the direction of my motion at all. Okay, so I'm not going to be able to steer out of it. All right, like less friction and less control. Let's see, creative in a synthetic way. Yeah, I know, but that's even a fake word, because all of our creativity is synthetic. The point is that it's creative in an accidental way. You know what I mean? Like words rhyming. That's sort of accidental creativity, right? Like if I find an analogy based on a word that rhymes in two different subjects, I haven't really found the analogy, right? I'm cheating. All right. It's like it took a video you made and it replicated into a podcast style. Yeah, but it did it by creating. There's parts of it that are just verbatim me, okay? And then there's parts where it's taking my metaphor and enhancing it. Where it's improving my metaphors or my analogies. So that's the part where I'm saying that part is interesting. Because to do that improving, it has to reference a lot of speech making, I guess, to find the rhetoric that makes that reasonable thing to do. It's making, let's just say it's sort of making accurate jokes. Its jokes are almost pertinent and relevant. But anyway, that's the auto, but it's, like I said, you can still explain that as autocomplete, not thinking. So, it's getting to the point where understanding that the mechanism can't understand. That's why it makes the colossal mistakes. Like making a 4-mass big, it's a 4-mass small and making the 1-mass big. Those kind of mistakes, it really shouldn't make if it understood what it was saying. All right. Well, anyway, back to the subject. Well, the story so far. All right. So this is the simple free fall kind of argument, and how this isn't an equivalence thing. You can't make equivalences between how you are launched, let's say, by something and given a velocity, and now you have a constant velocity, and something giving you an acceleration, because only gravity can do this thing, okay, where it can accelerate you without you feeling it, because only gravity can accelerate your electrons and protons evenly. So it moves your hand just the same speed as it moves your head and your feet, and they all go at the same time, and they all move the same speed. And that's why you don't feel free fall. You don't feel like you're being accelerated, even though you're going faster and faster and faster. So if I put you in a circumstance where you couldn't feel any wind, and I threw you out of an airplane, you wouldn't have any idea. The wind really makes it, you can understand it because the wind, it gets intense. All right, so when you first jump, not so much wind, all of a sudden, you get up to your terminal velocity and the wind is intense. The pressure being pushed on you, so you're feeling it a lot. So let's not get a joke about, what free fall really feels like. So free fall for astronauts is completely different because, yeah, they're in a protected environment. So they're feeling it the way it is, in the sense that all the parts of their body move at exactly the same speed, and they can't tell whether they're going 500 miles an hour, 5,000 miles an hour, 50,000 miles. It would all feel the same because they can't feel any of the acceleration. And it's only gravity that can do that. Nothing else can accelerate you that way. There's no other force that can. So there's kind of nonsense to talk about an equivalency anywhere, because there's really nothing equivalent to gravity. There's no other force that can do this, okay, except for something like an intense amount of magnetism might be able to do it, or an intense, yeah, it'd have to be magnetism. Charge couldn't work because that'd be too much for the surface. That would pull on you. You'd feel the difference. So it's just, it's just that fact that we can only feel disruption when something pushes unevenly. Like one spot it hits. If it hits everything at once, I can't feel it. Simple fact. So, this is where they just turn science into some touchy-feely nonsense and pervert it and misunderstand it. But it's really not the same. Being accelerated by a rocket and being accelerated by gravity are not the same thing. All right. So, rockets. So this was the one where they got it kind of stupid, in the sense that all of the images produced by the AI have flames coming out of both ends of the rocket. So they kind of missed the idea of using thrust to turn the rocket. So the idea would be is you'd have the 1,000 mass going 1 mile an hour out one side, and the 1 mile an hour, the one mass going 1,000 miles an hour coming out the other side. And so it's basically the gun and the bullet, right? That's all you're doing. You're just arguing that if you put a gun, you had the recoiling gun go out one side and the bullet go out the other side, you have 1,000 times different amount of energy. You have 1,000 times more energy going one way than you have going the other way. And yet, obviously, the spaceship's not going to see any of that, because all it sees is the momentum. And it's the same with this exhaust that lifts the rocket off even. It's the only thing that's going to happen is this equal and opposite reaction to the momentum. So you could calculate the kinetic energy of the exhaust. It'll be 1,000,000 times more than the momentum, but it won't make the spaceship move with 1,000,000 times more velocity. It will completely fail. There won't be any kinetic energy, okay? The KE in the flame will not be the same as the KE in the rocket. There won't be an equal and opposite reaction. So it violates overtly. Pie in the face, right in your face, violates the third law. And yet people defend this. Why? Why are they pretending that there would be any point in anyone talking about the third law if the most important form of energy, kinetic energy, didn't obey it? So if the most important kind of energy in the universe doesn't have to obey the law, why is it a fucking law? Who are you trying to fool with something this silly? Why would we pay any attention to Newton's laws if the most important energy in the universe you can create isn't covered by the law? It's like having a law for things that don't exist. Like I could describe some kind of alien that doesn't exist on Earth, and I could pass a whole bunch of laws against those aliens, telling those aliens how they have to live. What sense would that make? Oh, that's right. It would make no sense at all. Newton wasn't stupid. Okay, so obviously the third law does not apply to kinetic energy because he didn't believe in kinetic energy, and that's the absolute truth, because it's a nonsense. It isn't true. There's no need for it. It doesn't fix anything. Squaring the velocity didn't fix anything in physics. There wasn't any part of physics that was broken that needed Leibniz to show up to fix it. It's just a fact. Momentum worked really well. For thousands of years, understanding momentum exchanges worked. And they just broke physics entirely with this nonsense. All right, so let's see what this guy says. To your point about the AI illustrations in your earlier video, it showed the gun argument with a round coming out of the gun barrel instead of a bullet coming out the barrel and the shell casing. Yeah, well, exactly. So that's a little more subtle. You know, that it didn't take the bullet out of the casing. You know, that the whole bullet with the casing came out of the gun. But I get your point. I mean, obviously it doesn't see, it obviously doesn't understand, because it would automatically see those kind of mistakes, you know. So anyway, coming out of the ejection port. Yes, well, anyway, the point is it isn't, yes, it makes like glaringly stupid mistakes that are almost inconsistent with how much it does right, you know. And it's obsessed with gears is the thing I find funny, though. It's like I can't get it to not make a drawing that doesn't have gears in it. So it associates this physics so much with gears, you know, that there's almost, oh, no way I can get it to draw an image that doesn't have a gear in it, you know, which is funny. All right, so have I said enough about the rocket gun thing? Well, this is the rocket gun thing. I mean, you can just turn this way and you can just understand that these things have to be equal, okay? The recoil of the gun, the heavy thing, the light thing, it doesn't matter what you're talking about. It has to be the same momentum. It is an equal and opposite reaction because these are explosions. Just as much energy goes this way as goes that way. It pushes on what's ever available fact, you know, and you just can't change that fact, and especially in the case of, you know, when you really analyze what a rocket is really doing, which is just throwing matter out, away. And so it's really equal and opposite reaction dependent, and kinetic energy doesn't work. So even if you think it takes 4 times the energy to throw something twice as fast, it doesn't matter, because the simple truth is the momentum will always work as a way of analyzing the rocket, and the kinetic energy will always fail. It's just an absolute fact. You cannot possibly get the right answer. You can't land on the moon using kinetic energy and thrusters. It's impossible, because the numbers are just plain wrong. They won't make the ship move that way. It won't happen. So, that is the way I decided to show water, or the hydraulic argument. So you can do this with water wheels. You can do this with a hose and just turning the nozzle, just recognizing that you're making the space that the water can go through smaller. The speed increases, okay, the density decreases, but the speed increases, and so the net amount of stuff going through is exactly the same, but it's going through at, you know, clearly this different speed. Okay, past a point. So it has more kinetic energy here, and has more kinetic energy here, and it has less kinetic energy here, and less kinetic. So how can it do that? How can the water molecules somehow go from having, you know, 200 joules, 400 joules, 200 joules, 400 joules? How can they change how much energy they have? I mean, it's just a nonsense to make this argument that somehow this is possible, that this is how the world works. And obviously the simple solution is to just say momentum here works perfect. Once again, there's the same momentum in the blue pipe as there is in the orange pipe, and the same momentum, same momentum, same momentum, same. It's same all the way through. There's no change in the momentum of the molecules in any cross section of you know, this pipe, and demonstrating that you can't make free kinetic energy, or you can't destroy kinetic energy. Kinetic energy just won't work. I can't make or break energy. I can't destroy energy by, you know, turning the nozzle on the hose. I can't. It's just wrong. It's just, and this, you know, this is what you lift cars with, this whole hydraulic thing. You know, the pressure is even across all the surfaces. You know that you can have, you know, a cylinder that's twice the size, and then a cylinder that's half the size, and the half size will move twice the velocity. I mean, all these things are known facts. So this shouldn't be argued. Okay, kinetic energy doesn't work in any of those circumstances. It won't get you a right answer. Anything close to a right answer. All right. So this is the sort of the Bruce Yanni, whatever, video where he did the blocks on the rubber bands. That's the only place I've seen this really demonstrated. But, I mean, it's a fundamental argument, again, just kind of a decisive proof that if I take the same explosive and I have, in one case, I put the explosive on a, right on a wall that can't be moved, it's too heavy, it's stuck to the ground, it won't absorb the force, it won't allow there to be linear motion. And the simple truth is then I put an object in front of it and I'm going to get more velocity because all of the energy has to go the one way. It has to reflect and go the other way. So if I don't allow the energy to be absorbed, I don't allow an object to move, it will have to go the other way. Now you could argue that if I do this with a gun, let's say I mount a gun, and so there can't be any recoil because I mount it securely. And so the gun can't absorb any energy. Well, the fact is that explosion is happening so fast and the bullet's moving so quickly, so fast, that probably all I'll do is increase the exhaust that comes out of the gun. I won't be able to make the bullet go substantially faster, but it might go somewhat faster. But the simple argument is if I put the same explosive between two objects that can move, I'm going to get much less velocity, half the velocity in each object. And the simple truth is I'm going to have much less kinetic energy. And obviously, I can't make different amounts of kinetic energy come out of an explosion. It has to be the same amount of energy. The bullet, if I put up two big bullets in the, if I make a zip gun, I guess I should have done the zip gun drawing. Maybe I can do that now. I can't make the gun produce two different amounts of tests. I can't test the energy and get the answer that, it has two different amounts of joules of energy that it can produce. It can only produce one amount, and that's it. So there's a thing called a zip gun, where all you have is really a straight barrel, and you just basically ram a bullet with a stick, and duplicate a gun. But it's a pretty poor duplication. But the fact is you could just use that for this type of experiment. The only thing we're going to argue here is that you can't change the momentum. So I could put two big bullets in, okay, and I could have the same explosion in two little bullets. And the truth is, okay, if I do this experiment with the same explosive in both cases, the fact is that, they're going to claim that somehow I can produce different amounts of kinetic energy. Somehow the same exact explosive will produce different amounts of kinetic energy. Now, it won't produce different amounts of momentum. So we already know that, if we do the MV thing, that the MVs will be conserved. The MV here will match the MV here. And if I put a big bullet and a small bullet here, I'm going to get the same MVs. And we know that this MVs have to match these MVs. They can't be any different. So it's going to be the same amount of mass and velocity. Obviously, I have a small bullet with a high velocity. That means the high velocity, let's say this is 1,000, and this one's only going 500. And, the bullets are twice as big. You can understand that the kinetic energy number, because of the V squared, is going to be ginormous, okay, 1,000 squared. And they're going to get different numbers. But how can they be different numbers? It's the same exact explosive. It can only produce the same amount of energy every time it explodes. And it's going to convey most of it to your bullets. There's no obstacle. There's nothing preventing the energy being absorbed by the projectiles. And it will be absorbed by the projectiles. And so it makes no sense because the experiment basically will prove that momentum is always conserved, and it'll demonstrate the kinetic energy is nonsense because the lighter the bullets, I keep getting a different amount of energy out of the gun. You can't do that. All right. I found the podcast style very good. Would be nice to see these arguments in front of a jury, so to speak, and have physics get on track and doing the necessary experiments to make it decisive. Yeah, I'd love to hit the whole idea of a courtroom for everything. It'd be nice to mimic courtrooms about all subjects that could be debated. It'd be all politics, everything should be debated in courtrooms. And it's like we can't get to any courtrooms, right? And the judges are all corrupt. But the idea of a courtroom, the idea of establishing somebody who's earned the right, a jury of peers are betters. I mean, it'd be better to have a jury of betters than peers, right? Um, and and accountable ones. That you're accountable for what you claim, and what you decide as a punishment, so to speak, or a declaration of the truth. And that your reputation should be on the line. That for all of history, we can call you a son of a bitch if you made a bad judgment, a sloppy judgment about what the truth is. And I'm just saying, if a fair cop sits on this jury and analyzes all of these statements I have made about all of these subjects, there's no way they can say these are settled. There's no way they can say, oh, yes, they're satisfied their need to prove the case, and we can convict as a heretic, anyone who disagrees. Bullshit, you can. All right, so this is the ballistic pendulum. Again, just decisive evidence, that there's just no viable way to explain this stupid kinetic energy theory, in the sense that you can't, even if their claims were true, they'd be in giant trouble, right? So the idea is they're going to say, okay, 99.94% of the kinetic energy is missing. So it doesn't get transferred from the linear motion of the small object. It doesn't get transferred into the big object's linear motion. Fails entirely. And they're claiming it's because the linear motion was turned into a bunch of little motions, little things moving. Now the problem with that theory is all of the momentum is almost conserved. So you're conserving 95% of the momentum. So how can you conserve 95% of the momentum and yet make a whole bunch of heat? Because the heat really does have to be made out of momentum, as I made the argument earlier. Heat is momentum. Heat is mass moving. Every time mass is moving, that's momentum. So you can't make a bunch of heat and conserve your momentum as linear motion. You can't do both. So it makes no sense at all. And of course, they've never tested it. So they never put a thermometer in the ballistic pendulum and said, see, look, here's all the heat. Nothing like that. Never even tried to prove it. They just make these silly claims. And it's a gigantic difference. Like I said, it's like 1 million joules of Ke in, and there's only 1,000 joules of Ke out, kind of thing. I mean, just gigantic, 1,000 to 1 differences, where the momentum is perfectly conserved, almost perfect. I mean, 95, 98%. I mean, really good numbers. 1,000 momentums in, and you're getting 998, momentums out. I mean, just a dead proof, okay, that kinetic energy is nonsense. It just can't be considered viable. I mean, I should draw the pulleys, which, is also an example. The lever. I don't think I have a drawing of a lever here, but I might as well draw a lever. Because their drawing of a lever was okay. I mean, they had a couple of interesting ones. There were gears on them, and they weren't the right length. They got the length of the levers wrong. But I figured that was a small point. Nobody would get too upset about that. I mean, people should, generally speaking, be able to see past that tiny defect. So the simple principle is you have a lever, and you suspend it from above, okay, to make it into a balance. And you put a 4 mass at one distance, and you put a 1 mass, okay, at 4 distances, and it balances perfectly. And it balances perfectly, as I have explained, because when the lever tilts, that is, when it tilts up, okay, and it has its suspension point, what it's actually doing, when the lever points up, it's going to actually be moving mass that was on this side to that side, okay, because the line that would define, okay, the straight, or the normal, you could argue, okay, that line, this is the amount of mass that's now moved over to that side. So as it goes up, it's getting heavier and heavier. And then as it moves the other way, the other side gets heavier and heavier. So it's switching the mass. It's throwing the mass from, when this side tilts up, the mass is getting thrown that way. When this side tilts up, then the mass is being thrown on that side. And that's the only thing, that's the engine, okay, that's creating the oscillation. So these masses are irrelevant. The only thing, because they're even. The balance is basically saying moving the 1 mass 4v is the same as moving the 4 mass 1v, no matter what the v numbers are, right? It's just 4 times the velocity here, 1 unit of velocity over here. It doesn't matter what the actual speeds are, it'll always be that way. The lever forces that relationship, and it's always balanced. And so the only thing it's getting imbalanced is where you're putting more gravitational mass on this side of the lever. So when it goes up, this side gets a little heavier, goes back down. Then as it goes back down, this side gets heavier, and it pushes that side back down. And that's the engine of the oscillation. But it's a decisive proof. I mean, it's just sitting here decisively saying, okay, how do you rationally defend any notion, okay, that there's 4 times the energy over here? How do you defend that? How do you defend that there's 4 times the energy over there? It's just it's nonsense. You can't defend that. You can't do 4 times the work. It's the same energy. It's the same amount of mass that's moving it. The same gravitational pressure is pushing it. It can't possibly do more work. It's just terrible. All right, let's see. Okay, I was thinking about how physics thinks photons wave and how they believe they've done the Eddington experiment many times. Well, this is, I don't think physicists think that. But clearly these buttholes who think they're science defenders, they actually think this is true. They actually think that these silly experiments, somebody takes a tin can and puts a lens in it and then does the Eddington experiment. Somehow that's doing the Eddington experiment. Somehow it really happened. That's a real experiment. We should all be impressed. I mean, it's so frickin' ridiculous. So yes, it hasn't been duplicated from Earth successfully outside reasonable margins of error. So unless you just forget about the whole idea of margins of error, it hasn't been duplicated from Earth anywhere close to credibly. And the very fact that they haven't even tried it from space, I mean, how can somebody believe that? How can a science lover believe that occurred to nobody at NASA ever to try the Eddington experiment with all their cameras and all their satellites and all their space shuttles and all their time in space? I mean, they've had astronauts just sitting in that stupid little box for months, and it doesn't occur to them to stick a telescope out the window and do the Eddington experiment? Come on. It doesn't make any sense. 400 times better seeing. 400 times easier to do the experiment. You don't need an eclipse, and it takes 5 minutes. And we're supposed to believe they never even tried it. You can videotape it now, with modern technology. It's just ridiculous. But photons have to work in straight line vectors. Well, it's just a fact of all of the lensing math proves that it's a straight line vector. So, I mean, I don't know why anybody believes why anyone believes photons have anything to do with waves, especially like when Newton diagrammed how a rainbow works, and it's all these little vectors inside the round water droplet, right? And it's all vectors. How can people think this is about waves? It's just ridiculous. All right, would be interesting what AI thinks about the Eddington experiment and the double slit experiment. Well, it doesn't think. The problem is it doesn't think, so it just goes based on what it's been told. And unfortunately, the vast preponderance of what it's been told is that somehow Eddington proved it and somehow 400 other experiments verified it. And there are no 400 other experiments that verify it. They have no image data, right? So what they're doing is cheating. So they're sending radio waves through the dirty part of the sun, the corona, where all the electrons and protons are. There, they send a bunch of radio waves through there, and it scatters everywhere. So of course you can see it from any location. You would say, hey, it lensed. So it doesn't matter where I go, I would see a distortion because it's scattered. And they haven't even, they're not even honest enough to say those experiments have this catch to them, that they're deceptive because scatter can produce the illusion of a bent when it didn't bend. It just got scattered. it's just, they're so dishonest. I mean, anybody who does any fair analysis, you have to admit that this is very dishonest, that nobody says about anything, that he said right in his journal, I wouldn't stake my life on these results, and he pointed out that he got 1/10 of the data quality. He said it overtly. I was hoping for 10,000 stars, I got 1,000 per slide. You know that's a terrible experiment. You know it's junk, garbage. Nobody who cares about science would say, oh yes, please do that. When you're going to diagnose me of having cancer, please do the experiment that sloppy. Who would want that? You want 1/10 the data to decide what kind of surgery you're going to get? No, you wouldn't accept that from a doctor. Why are you accepting it from a scientist? I mean, you people are such fucking hypocrites. You're such fucking lying pieces of shit to sit there and make these dubiously moronic arguments defending science that never has tested any of this shit. They haven't dropped 4 pounds 1 foot and 1 pound 4 feet. I mean, they haven't done a damn thing to get to the goddamn truth. They've done everything they can to evade the truth. And you defend this shit. All right, the Mythbuster episode when they fired the ball out of a cannon attached to the back of a vehicle at 40 miles per hour. Driving at 40 miles, showed the ball drop. Yeah, okay, with a straight down thing. That's not that's not challenging kinetic energy at all. Right? I mean, the only thing that's proving is that the only thing that matters is momentum in rocketry or explosions or firing things out of cannons. The only thing that matters is momentum. You can't collect any of the kinetic energy. I guess it's a good argument, right? Obviously, the gun is producing 1,000 times more energy out one end than the recoil. So obviously right there, the violation of the third law is already obvious. So I guess we don't need this other experiment to show the violation of the third law because we already have a very obvious violation with every single time a gun is fired. Right? So that one's already been proven. All right, kinetic energy showing up to propel the ball exponentially. So I don't know what that means. Not kinetic energy showing up to propel the ball exponentially. Yeah. Now, I don't know what to say there because you're not measuring energy. You know. So they're just going to say the MV still goes that it has this huge amount of kinetic energy. Yeah. I don't know. I don't know how to interpret that any other way. Well, think about it. I guess I'm just not seeing the angle where it demonstrates the flaw in the kinetic energy theory. Beyond the obvious flaw that the gun already illustrates. Okay, anyway. I should be saying that AI generates. I don't know what that means. It was raining, possibly the same day the experiment was. Yes, exactly, done. It wasn't the same day. It was 5 minutes before the eclipse. It was raining. So the atmosphere was full of little, water droplets, obviously. So obviously it was crappy conditions. That's why he got 1/10 of the quality. I mean, 1/10 is a gigantic degrade. To get 10% of the data, that's a gigantic degrade. I mean, and for me to be the only person that can acknowledge, to say that, the only person that can make this accusation in 350 years, it's occurred to nobody to read the journal, see that silly statement, I was hoping for 10,000 stars, I got 1,000, and say, that's a dead experiment, right? That experiment's over. There's no hope for this. This was already a really difficult experiment, right? They spent a ton of money. They dragged a 12-foot long telescope up a mountain. I mean, this was, this was not a simple experiment. And it was on the margins, even in good weather. And it wasn't even a perfect eclipse, right? It was a 1:30 eclipse, so it wasn't even a 12 noon. We had a North American eclipse that was dead 12 noon. You can't get better. It's just so ridiculous to have these arguments. Yeah, it was the same day I read somewhere. Like I said, it's 5 minutes. I'm just saying it was 5 minutes. He says it right in his journal. 5 minutes before the eclipse, it was raining. 5 minutes. And this merited a New York Times headline saying Einstein proven right. So let's just understand this experiment made Einstein a household name. This experiment did it. And this experiment is a pile of crap. And the fact that we don't have anything from space, 50, 60 years of telescopes being in space, and we don't have a single effort to do a lensing experiment. I mean, you could do it with Jupiter. I mean, the advantage of Jupiter isn't that bright, right? So, and you don't have a bunch of electrons flying off of it. It's not on fire. So you can get really close to its gaseous surface. So even though it's, 100 times less gravity than the sun at that location, it's 100 times cleaner, So it's still a pretty good location to try the experiment from. And they never even tried it. Einstein even sort of suggested that it would be possible to do the experiment using Jupiter. But, does scientists recognize that? Do we acknowledge that fact? No. Do any of these defenders acknowledge that absolute truth? No. All right, so this was the giveaway experiment, really. This is the one that got me on this subject. I saw a physics girl video where she was defending this nonsense. And I was like, what the hell? You mean physicists really believe this? This is my holy shit moment where I said, I can't believe they actually think this crap is true. Where you could have a 5 mass going 10V, and you gracefully drop 5 mass on it. And now you have a 10 mass going 5. And it's really, really conservative. So when they do the experiment well, you'll see that it really does conserve 99.9% of the momentum. I mean, the numbers are incredibly clean because the dropping force, the force combining the two, is in the opposite direction. So it really doesn't disturb the velocity. You don't have to use the velocity to combine the objects. Gravity's being used instead. So anyway, it comes out really close to 100%. And then they're making the argument, we lost half the kinetic energy because a whole bunch of deformation happened. Things got broken, pieces flew off. There was all kinds of horrible sounds and heat came flying out. None of that. There's no obvious anything. Okay, no catastrophes anywhere, no bits flying off, blinding you, nothing. And they make up this story. And the obvious story is the same one with the bowling ball kind of argument. How could I make a bunch of heat and knock down the pins? I can't do both things. It's impossible. If I'm making heat, then I'm losing my energy to friction or something that's causing the heat. I can't possibly deform something, which is converting it into heat, and not lose my momentum. So I can't have 100% of my momentum and have lost 50% of it and made heat. I can't do those two things. It can only be in one place. It's either in my linear motion, the 10 mass is going 5V, and my momentum is in my linear motion, or it's in heat somewhere. But it can't be in both places. And that's their big lie. All right, is that there's any evidence that there's any twice the half of the kinetic energy has somehow been converted into some dissipated heat. No test, no evidence, nothing, no experiment showing any such thing. And again, the logic makes it impossible to believe. It can't be true. You can't have heat here, okay, and all the linear motion going here. You can't do that. You can't make heat out of nothing. Ugh. All right, sorry to get off the subject from momentum versus kinetic energy. Well, you weren't really off the subject. I don't think. Oh, yeah, well, the Eddington experiment's off the subject, sure. But it's the same subject of the big denial. The fact that they just misrepresent the absolute truth. They don't acknowledge any of these points or these experiments at all, that these experiments haven't been done, just like this one up there. They don't explain that. It's the same exact force being applied to two objects. One of them weighs half as much as the other, and it's clearly not having an inertia problem. It's here clearly not being prevented from going twice as fast. It's going twice as fast. It's not going 1.4. So explain it. Explain why it's not having an inertia problem. Okay. All right. One of the fucked up things about that video is the matter-of-fact way she tried to justify KE. I don't know what you're talking about. When she had no facts to back up her claim. When I don't know who you're talking about. Oh, that was, oh no, I don't know what the she is. Not kinetic energy. Let's see. I don't know. That was a Mythbusters one you're saying. I don't know which one you're saying. Oh, physics girl. I'm sorry. Just no, and to show a tomato getting exploded by a bullet or something. They had this huge explosion thing to illustrate the deformation argument. And you're like, that's not what happens in the experiment, okay? Nothing, there's no tomato on the walls, okay? There's nothing, there's no explosions here. This is a graceful combination of these objects, and the very fact is you can see how graceful it is. And so that was just such a lie. It's just despicable that they get away with this. And the real problem is why they get away with it is because the majority of people, including scientists, are really just religious fucks. They're really just lying, sycophants to, silly fables and nonsense stories. They're all living in pretend worlds, of delusions. They're all little kids, My Little Pony or something. They're not living in reality. It's Smurfy people or something, Pokemon or something. I don't know. It's just bullshit. Why they're attracted to fables and nonsense, I just can't answer. All right. So this is just a pure illustration of the simple truth of charge. How you can get electrons to repel each other and protons and electrons to attract is all you need to do is have two elements of matter for, two elements of force that are the same, that electron force and then proton force, and then just have this third interaction. So the force can stick to the same colored object, it can reflect off the same colored object, or if the wrong colored force hits a wrong colored electron or proton, it just turns into the same force that the object is. So you have absorption, reflection, and conversion. And those simple things will create an electron that just radiates electron force and a proton that just radiates proton force. And those things will make electrons repel each other intensely, and they'll make electrons and protons attract intensely. But it's a little bit, it's a longer subject, so I'm not going to do that in this video. But the simple argument is that leads to charge, creates this phenomenon where obviously I think even Maxwell could explain to physics that if you want to get two positive charges really close to each other, the simple answer is just put a negative charge in between them. And that's what really happens inside of nucleuses. Nucleuses have electrons in them. And the electrons are merely the catalyst that allows protons to be very close. Because there's no pressure between electrons and protons, and there's very high pressure between protons and protons. So obviously if the protons can't see each other, they can't repel each other. Duh. And it's really that simple. So the whole fake strong force, this bullshit made up force that magically only happens in this little tiny space, and it just stops happening, and it only affects these little things. First it only affected protons, and now it affects these quarks. They made up a whole new story for it, but it's just Alice in Wonderland nonsense. It's all a fake fable. It's all a nonsense story. Gluons, puons, zooons, it's all just nonsense. And this simple mechanism, just stick an electron between two protons and you will get them insanely close to each other. Alright, I don't really know how the future will handle these arguments, but I definitely needs to happen. Kinetic energy is a phantom, and momentum is physics. Yes, it is. And it's just, like I said, it just requires such a level of dishonesty not to acknowledge all of these arguments. So all of these, I didn't even draw them all, right? I mean, these aren't all of the arguments. There's more arguments. They could be better made than I just made them. But they just all prove the point that this is not a viable mechanism, and that its history is terrible. I mean, I didn't even go into the Deschardelet clay experiment. What a pile of garbage. Joule doing his tank, right? And we've never used a Joule tank since Joule died. Nobody's had a Joule tank for some reason. So a perfectly sensible way to test energy, we decided never to use again once the guy was dead, which doesn't make any sense either. I mean, it's just so crazy that they don't even bother using Joule tanks anymore to do any experiments. But the whole idea of him dropping things on a rope, okay, in gravity, obviously the longer something takes to fall, when you're holding something against gravity and not allowing it to fall, it means it's going to be in more gravity. It's going to weigh its weight for a longer period of time. That means more energy. And the fact that they can't even figure that out, they can't really figure out that pointing an arrow doesn't mean it has more energy. Because they're basically arguing that anytime something penetrates further, it means it has more energy. When no, it doesn't. And it clearly doesn't. So here you have something that's just so overtly obvious that obviously pointing the arrow doesn't mean you gave the arrow more energy. And they know it. So they know their own rules about distance don't apply. So they know something else is controlling what energy is. Not distance. Okay. It's just amazing that they can't be man enough to honestly say, yes, the truth has not been pulled out of the fog here. In 350 years, they haven't done any good science on any of these elemental subjects. And energy, you can't get more important than energy as a physics subject. How can you get more important? And there's no experiments. They don't turn scales sideways. They don't measure 4 pounds dropped 1 foot and 1 pound dropped 4 feet. They don't do any of these simple experiments. There's amazing lying going on. Isn't pressure caused by resistance between two very dense objects? I don't even know what that means, but pressure is caused by any interaction involves pressure. Pressure is just weight. Pressure is just momentum. So anytime two things hit and they have conflicting vector arrows, okay, they are creating pressure. Pressure is just the net difference in the momentums. I grabbed something. Oh, yeah, there it is. Oh. So, there, I think I'm out of cards. A decrease in the surface area of an arrow doesn't increase its energy. A decrease in the surface area. Well, it's not just the surface area, right? It's the angle. Because what the angle allows you to do is push sideways. Just one motion. See, so this is, I didn't do like ocean waves here, but I could do ocean waves. I could do all this other stuff. See if I have a blank page in here somewhere. But the simple truth is that the non-pointed arrow means it has a flat front. So what is it doing when it creates its pressure? The pressure goes forward, and that's it. It can only go forward. There's no other option except forward. And so it obviously builds up a high pressure very quickly in front of it. So then it has to start pushing it sideways. So ultimately it has to go sideways, the extra material. But it has to push it forward first and then sideways. So all of that's friction. So now you're changing the direction. So you wanted the direction to be in one direction. You wanted, your linear motion to be in one direction. And now you've essentially lost, most of your energy, okay, to doing that conversion. So, so the pointed arrow, and so this is relevant to Deschardelet and the round thing, because it's sort of the same argument. So you're making a comparison between this surface and this surface. And obviously, as this goes into a surface, it's got to push this way, okay? There's nothing pushing sideways. Obviously, the arrow is pushing substantially, okay, sideways. Okay, a large percentage of the push is just sideways. So this is pushing forward, and then the extra material, because this gets to be a high pressure, right? The extra material has to go this way. So what you're doing is two motions. You know, you're going this way and this way. And obviously going this way has nothing to do with going forward, so now you're dissipating, okay? So now you're doing this scattery kind of thing where you're going to convert it into a lot of heat. So this is creating a lot of heat, where this is very efficient. It's just getting rid of the material in one direction and getting through the material. So it's much quicker. And obviously round objects effectively, okay, are doing the same thing in the sense that round is flat here, okay, and then on the sides it's got a good tilt. So obviously the deeper it goes, the more it starts pushing sideways, and the less deep it goes into a surface. So if it just barely dents the surface, it's still pushing mostly down. And the deeper it goes into the surface, right, then it's pushing sideways a lot more. So it's got a vector, you know, when it's got a low velocity, 1 unit of velocity, it's, you know, let's say 80% down and 20% sideways. And it's exactly the opposite when it goes deeper with the 2 velocity. It's doing 20% down and 80% sideways. So that's why it's not a credible way to measure energy, because it's not moving absolutely more stuff. It's just moving it more efficiently. So like a water wave has to push forward. It's uncompressible. It can't go down because the ground isn't compressible either. So where does the pressure go? It has to go up, because that's the only place it can go. That's the only place it can go where the pressure required to move is lower. Forward is too high, down is too high, so it has to go up. Let's see. A decrease in the surface area of an arrow doesn't increase. Okay, sorry. Sorry, my pressure statement was specifically referencing subatomic particles. Doesn't matter. It's all momentum, so I'm just arguing that it happens in the subatomic particles first. They're obeying all these rules. So I'm just saying the fact that the conservation has to happen in that universe. The universe of electrons and protons is where the conservation is really happening. And all it really is in that universe is, as I've attempted to describe, it's just a Sisyphus argument. There's just pushers, okay, the force bits, all right, and there's boulders, the electrons and the protons. And so all the Sisyphus can do is it can push and stick and then push a boulder. If the boulder's moving against it, then the Sisyphus that's already stuck to it has to reflect. So then both of them reflect. And the third option is, yeah, if I have a red Sisyphus hitting a blue object, it comes out a red Sisyphus. And that with that simple mechanism, I can create charge, perfectly duplicating Maxwellian charges. But that simple in a mechanism. You don't need anything more complicated. Something that simple does the job. But yeah, still, there's no resistance. So resistance is a silly concept. I'm just saying there's no nothing resists being moved. You have to give it energy to move. A bucket is dry until you pour water in it. If you don't pour any water in it, it stays dry, right? It's not resisting the water, is it? No, it's not saying I won't be wet. It's saying, go ahead, give me water, and I'll go. But until you give it to me, I'm not going anywhere. Force is real stuff, and it's real momentum, and it spends real time pushing matter. It's absorbed from an environment. It's taken out of the environment, made to push boulders And when you do that, there's less force going wherever the Sisyphuses were going. They're not going to get there. That's the gravity you're falling in right now. The Sisyphuses that had to go through the earth haven't gotten to me on time because they're busy pushing boulders. So they're not showing up. The ones from the space are showing up right now. The ones that are supposed to be here aren't going to show up for a little while, and so I fall in that deficit. But you're really off the subject. I mean, everybody should just be saying, yes, physics needs to do experiments. Yes, they haven't done any of these elemental experiments. They haven't analyzed any of them honestly. Again, something that simple. Right there is a huge piece of evidence against the kinetic energy theory. It's saying, there's no evidence that that yellow thing got twice the energy from the same fan. The same fan, same wind blowing, it can't get twice the energy. How come it's going twice as fast? Because now it has twice the kinetic energy. But it has exactly the same momentum. So by momentum theory, everything's just fine. It makes perfectly good sense. Twice the force, half the mass, same amount of energy. Momentum works fine. Why do you need to break momentum? Why do you have to reject momentum and say something else has to be true? What experiment makes you believe in kinetic energy? Where's your evidence? Show me where it takes 25 times the fuel to go 5 times as fast. Why? Why do you believe it? Why do you believe in this silly theory? What experiment makes you a believer? What fucking experiment makes you a believer? What experiment makes you a believer? Where do you get it from? What have you seen that makes you think, okay, energy is exponentially increasing with velocity? Yeah, valid questions. All right, well, I guess I will call it a video. Haven't made one in a while, live video. Just because, yes, it is all, the AI is making it clear, it's saying it better than me. So that's true. It can talk better than I can. Yeah, and I've been over these arguments so many times, and it's like, I mean, till there's nothing you can really do, right? Because the internet doesn't provide a mechanism. I can't even, realistically, I can't even in any honest way pay for, some sort of viewership, a reasonable price anyway, right? I mean, I suppose, yeah, I don't even say take my money. I mean, I don't know how much Sabine Hassenfelder would require me to pay her to be her 2-minute commercial she'll do in the middle of the video. I mean, I don't know how much you have to pay in cash to be that 2-minute commercial, But obviously we need more people to engage in this conversation, to explain why it's okay that Eddington only had 10% of the data. Why that makes it still a really credible experiment. 10% of the data, not a problem. Why can't somebody explain to me that truth? Make that a real argument and say, it's not really important. It's so obvious, that what do you need real data for? What do you need a credible experiment for? It's so easy to do. Sorry again I wasted your time. I don't think you wasted it, but whatever. A little hard on yourself, I think. Yeah, sorry. Look, I'm a little bit impatient and all that crap, so you shouldn't get too, wait till we really, start insulting each other's mother before you start worrying that, we're having there's some sort of problem for which we need to apologize. Yeah. But yes, I mean, it just reminds me of the dickhead, the Rousseau guy, and the fact, now he's making garbage videos that who could care to watch. And, I left him with the challenge. You have the air track. You obviously cheated doing the rubber band experiment. So why don't you put the 4 rubber bands on? He says it takes 4 rubber bands to go twice as fast. Not just 1 rubber band, not 2. 2 rubber bands won't do it. Not 3 rubber bands, that won't do it. You can't go twice as fast. You need 4. Why doesn't he do that experiment? Show us it takes 4 rubber bands to make something go twice as fast. 4 times the force. And he obviously cheated. Like I said, it's just obvious that his computer software glitched, you know, and he left the video up like it's a good piece of evidence. I mean, anybody who knows anything about this software stuff knows glitches really aren't acceptable. I mean, it's not good science to have a glitch in your computer software demonstration where it doesn't work the way it's supposed to. That's not a good thing. Not working the way it's supposed to is not what you want to have happen in an experiment. And it was glaring and obvious, and yet there's been no retraction, no effort to redo the experiment, nothing. No counter to the accusation that it's just fake physics. Because he can get away with it. Because there's people more willing to believe a lying piece of scum telling the story they want to hear. Okay. And that's it. They'll defend lying. They'll defend completely substandard experiments. Again, they'll defend. It's just an absolute fact that Eddington said in his journal, I was expecting 10,000 stars, I got 1,000. I should put that in Google and see if I can find the goddamn journal. It used to be online, right? So the internet's gotten so shitty that all the stuff that you used to be able to get on the internet, you can't get on the internet anymore. So I can't find Eddington's journal. You have to pay to see it. You know, it's in some book or it's in something you have to pay for now. I'm not a pay kind of person. But anyway, so, you know, that's what we're standing here saying, you know, who defends that? But that's what they do. They'll defend anything as long as it's telling the story they want to hear. You know, their favor, their religion, their little, you know, wooey verse silly shit that they bow to and pray to. It's just disgusting that these people pretend to be reasonable, rational atheist types. You know, people impervious to bullshit. You know, no, they live for bullshit and they'll fight for it aggressively. I mean, they'll invade your personal life, do all kinds of weird shit in their grand effort to preserve these giant lies of science. It's disgusting. It really is disgusting. What a disgusting planet of jackasses. Ridiculous, lying, dishonorable. I just never realized that most of the world was black hatters. You know, I grew up watching The Lone Ranger, Underdog, you know, Superman, you know, looking for a hero. Obviously, you people are just, you know, all these, you're Simon Bar Sinisters. You just want to break and ruin and smear your poo on everything. Disgusting creatures. Disgusting liars. Like I said, there's just nothing to defend here. How the fuck do you defend an experiment where the guy admits, I only got 10% of the data? 10%. How can you defend that? In what, you know, in what circumstance would 10%, you know, 90% failure be acceptable? Like I said, if it was a blood test, you know, if you went to the doctor and he said, well, there's a 90% chance it's not going to be the right answer. Is that okay with you? Yeah, you'd say it's okay. Yeah, go ahead. Charge me $500 for that experiment. I mean, you people are just such lying scum. So anyway, enough of this. Enough. Why am I interacting with lying scum? Yeah, it's not my obligation. Oh, yeah, it is. Yeah, that's all there is. It's the only turds in the cesspool. Unfortunately. Just turds. So, I don't mean to offend the 4 of you on this planet who can think reasonably, but, yeah, clearly most people can't be reasonable, can't be fair. They don't even understand honor and dignity. Disgusting. It's just disgusting to have to live among you scum. So anyway, till the next time, such and so forth and whatnot. Yeah, I really do hate you fuckers.